Hi class, I am going to do a short video illustrating some of the multivariate plots we're going to be working on. So the first thing we should do is load these libraries. There is a new library called ggridges, so be sure to install that library if you haven't done so already. And then we'll be once again working with the penguins data set from the Palmer Penguins library. So the first question we're going to examine is to try to show the relationship between body mass in grams and flipper length in millimeters. So I'll start by using, the penguins data, and I'm going to pipe that into ggplot. And in my aesthetic, on the x-axis, I didn't actually say this in the question, but in the x-axis, on the x-axis, I'm going to put the flipper length in millimeters. And on the y-axis, I'm going to put the body mass in grams. And this time, the geom we're going to use is geom point, which will create points. So I will run that code and we can see our lovely points on the graph. Here it tells us that it removed 2 rows. There are some data points with missing values. You'll see in our class lesson that I show you how to remove those if we need to. Just a couple other things I want to show here is, in addition to geom point, another function we'll often use is, or another geom we'll often use is geom jitter. And I don't think it's going to show that much of a difference this time, but this is really nice to use if we have overlapping data points or data points that are right on top of one another. It gives each of them a little bit of, each data point a little bit of noise so that we can sort of see them as different points rather than the same points on top of one another. In addition to using geom jitter, you know, this data set is not that big, but with really large data sets, it can be nice to change the size of the points. So maybe make them half their size. And we can also change their alpha. This changes the transparency of the points. So perhaps we want to make them a little bit transparent. Again, these things are especially important when we have a lot of data points. You're not going to see a huge difference in this case, and it's likely we don't have to do all of these things, but nice to do when you have a really large data set. So in terms of describing this relationship, we often want to describe the form, strength, and direction. So in this case, the form, this would be a fairly linear relationship. So if we sort of envision some sort of line going through this to describe the relationship, it would probably be a straight line. Strength, we can talk about that a little bit more regarding when I talk about correlation. But, you know, it seems fairly obvious that there's a relationship. So I wouldn't say it's weak, but there is a lot, the points are quite scattered around this sort of line we might envision there. So it's probably not really strong. So maybe it's a moderate linear, and then direction sort of describes the direction the relationship is moving. So this would be a positive relationship, which means that large values of the variable on the x-axis are associated with large positive values on the y-axis, right? So positive values on large positive values on the x-axis associated with large positive values on the y-axis. Okay. And then we also want to make sure we call out any outlying points, which we don't see in this particular plot. Another thing we might want to do here, which I alluded to a moment ago, is to actually compute the correlation. So we can take our penguins data set and we're going to pipe into this summarize function, which you've seen before. So remember on the left, we need to name this new variable. So I'm just going to call it, correl for correlation. And I'm going to use this core function. So I need to give it my X and Y variables. So let's see, flipper length and body mass. Oops. If I can spell, so flipper length and body mass. And let me first try to run it like this. We're going to see that it returns an NA. And that's because there are missing values in these variables. So there's a lot of different things we can do here. I'm going to use this use argument, which essentially tells it ways to eliminate missing values. And I am going to, sorry, this is right in the way of my Zoom controls, of course. So I'm going to use the pairwise complete obs. So I'm going to put use equals, let's see if I can get this right, pairwise dot complete dot obs. Is that right? I'm going to try to run this. Yes. So what that does is it eliminates any row where there's a missing value in that pair. So if it's missing in just one spot, it'll eliminate the row or that observation. So our correlation is about 0.87, which is actually pretty high. So, you know, maybe I was wrong. Maybe I mischaracterized this. Perhaps this is a fairly strong relationship, certainly not weak. Okay, let's move on to quantitative versus categorical. So in this case, we're going to examine the relationship between body mass and island. So I like to think of this as examining how the distribution of body mass varies by island. So first, we're going to do this with a side-by-side box plot. So let's take the penguins data set. Oops, not that. Take the penguins data set. Oh, geez. I pressed the wrong button. Okay, let me see if I can press the right set of keys. There we go. Take the penguins data set and plot it. And I like to make these plots so that the categorical variable is on the y-axis and the quantitative variable is on the x-axis. So I'm going to put body mass in grams here on the x-axis, and on the y-axis, I'm going to put island. And then we will do a geom box plot. So we did again get some messages or a message saying it removes some rows because we had some missing values. So this is our side-by-side box plot. I like doing it this way with the quantitative variable on the x-axis because it's a little easier for our eyeballs to compare these box plots. And just to remind you what's in these box plots, the middle line is the median. That two ends of the boxes, the lower end is the first quartile or 25th percentile. And then the top of the box is the 75th percentile or third quartile. Then these whiskers or these lines that come out of the box either extend to the minimum and maximum like they do here, or they extend to a slightly smaller value and then they might indicate some slightly outlying points on their own. But this gives us a great way to a really simple comparison. So I can see really well here that the Bisco penguins are quite a bit larger than both the Dream and Torgerson penguins because they're 25th percentile for their body mass is above the 75th percentile for both the Dream and Torgerson penguins. Whereas the Dream and Torgerson penguins, their distributions overlap quite a bit. Their medians are the same, and much of their boxes overlap each other. So those are the sorts of things we're looking for here. Another way we might look at this is via a density ridge plot. So I'll take the penguins data set and go into ggplot. And again, let's see here if I can remember the right way to do this. So on the x-axis, I'm again going to use that body mass index, or I'm sorry, body mass grams. And on the y-axis, I will put island. And then I am going to add the geom, and it's going to be geom density ridges. And there's a lot of different arguments we can put in here to change exactly how this looks, but I think this is good enough for now. So remember, a density plot is sort of like a smoothed out histogram. So this is, showing us a little bit more detail of the shape than we saw via the box plots. So we can see this overlap a little bit more, how exactly that looks. We can also see more detail, let's say, between the Dream and Torgerson penguins. We can really see that their distributions overlap quite a bit. We're still seeing that these Bisco penguins, the distribution of their weights is quite a bit different from the other two. And then the last thing we might want to do, let's say up here, I might actually want to describe, let's say, the mean or the median. Maybe I want to know what those exact values are. And we can do that using some of our wrangling tools. So I'm going to take the penguins data set, and I'm going to use a function called group by. And I'm going to group by island. And this means that whatever I do next, it's going to do for each level of that island variable. So it's going to do that for the Torgerson, Bisco, and Dream islands. Okay. And what I'm going to do is I'm going to summarize my data, and I'm just going to do a couple things this time, but we could always add more. So let's do mean mass, and this is going to be the mean. What was the name of that variable? Body mass in grams. And I'm pretty sure there's missing values. So I'm going to add this na.rm equals true so that I can get rid of those if they're there. And then, oops, put that in the wrong spot. Let's make sure my parentheses are all lined up. Yep. So there's one variable. I'm going to put a comma here and add another variable called SD mass. And let's take the standard deviation of body mass G and also do na.rm equals true. That will give us the mean and standard deviation. And notice that it's going to do it for each of the islands. Okay. So we can see that the mean body mass for the Bisco penguins is much larger than the mean for the Dream and Torgerson penguins. We can also see that the standard deviation is much larger. Now, in this particular case, the distributions are slightly skewed. So these might be slightly affected by these sort of more tail points. So perhaps we'd want to instead compute the median and IQR as sort of better ways to compare them. Although they're not actually terribly skewed. So I think in this case, the mean and standard deviation are just fine. Okay, hopefully that was a nice, quick introduction for you for these sorts of plots. That's all I've got. Thanks.